Hey everybody. Continuing on with equilibrium. So let's say we've got an equation. I'm just going to use, we have chemical AB plus CD, and it changes into, let's say it makes chemical A plus B, C, D. Okay, keep that easy. And and let's also say it gives off some heat. Okay, so here we got, these are our reactants over here. These are our products. Now, if we've got an equilibrium reaction going on, we draw the arrow going both ways, like that, because some of this stuff can form over to here. This stuff, a little bit of the heat, this compound and this compound can form back over to here. Okay, so what happens is, if we remove something or or add something, we can shift this reaction. So right away, you add all this A, B, C, D together, stuff starts happening. You get a reaction, you get this stuff formed, and then the reaction almost stops, but a little bit of this goes this way, a little bit goes that way. Okay, now let's say if we were to, once we're at equilibrium, there's just as much of the reactants, just as much of the products being formed as the reactants are being remade. That's equilibrium, back and forth, real gentle. Now, let's say we come along and add a bunch more of something. So if we call this stressing the system, stress the system. So stressing the system, we can take away something, we can remove, we can add a chemical, okay, and that will stress the system. We're not going to get into this year. You can change the pressure. We'll save that for next year if you take AP chemistry. And heat, keep in mind in this product, in this example here, heat is it's a product, okay? It's also being made. So let's say we add, well, okay, I've got a little example here. So let me aim this up. So I've made this little teeter-totter here, and this is kind of representing, we got a reaction. When the reaction rates are equal, let's say we get a bunch of products here. Whoops, now I'm throwing stuff. Okay, we get a bunch of reactants over here. We mix them together, put a few more over here, okay? So what's going to happen is, these start mixing together, and they're going to be shifted over to the product side. And let me get these over here. Oh, we're not quite there yet. Okay, over here. Oh, okay, now, you see how this is kind of balanced now? What we're saying is now, this is going to represent that we're at equilibrium. We've got just as many reactants being formed as products here. Because some of these guys are going to move over here at the same rate that these guys are going to go over here. And so you got an equilibrium. But watch what happens if we remove something. If we take something away, of course, I'd take that away. Oh, let me get this out. Okay, I take this away. See how this end fell down? So what's going to happen is, just like with a teeter-totter, you get too much weight over here. This is no longer in equilibrium. So what has to happen is, these are going to begin to shift over here. Okay, now we've got this leveled off and balanced. We're back at equilibrium. Now again, this is the rate of the reactants being reformed is equal to this. Now, if we come along and let's say, hey, let's add some more stuff over here, all right? Well, what's going to happen is, you add more stuff here, we're no longer at equilibrium. Our teeter-totter's off balance. Okay, well, these things are going to start shifting, and you're going to start making new products. And at some point, there we go. Okay, so now we got it back at balanced over there. Oh, yeah, okay. Heat. Sorry, I forgot on my little example over here. Hope I don't burn down my garage. Okay, one of the things in our little project here, we said we had heat being formed here. So let me put heat over here. Okay, I got to remove one of those. Okay, so now, if we take heat away, okay, we can remove heat. If we remove this, see how, oh, wait a minute. That side falls down. We're no longer at equilibrium. We take away heat, which we can do by putting something on ice. Okay, in order to get this back to being balanced, we remove something here. the chemicals will shift to where we took something away. If we put heat back, okay, we throw this in a container of boiling water. Well, heat lives on this side. Okay, we add heat to this reaction. These things are going to begin moving back this way until, there, well, get over there. Oh, wait, okay, my analogy is falling apart. So there we go. So now what we get, after we've added the heat back on here, chemicals started to shift back over here to reach a new equilibrium. Now, on your paper, what I'm asking you to do is to, let me angle this down here. So what I've just done here, if we take away something, equilibrium shifts to where you take something away. It shifts, in this case, to the right. If we were to add more heat, if I add more heat right here, now we got a whole bunch of excess, it's going to try to shift it this way. And just think about these equilibrium reactions like a balanced teeter-totter. So you add somebody over here, this side goes down, and things have to shift to the left to get back in balance. Okay, so you can either write this now down in your notebook, or you can just print it up and put in there. I want to make sure, I'm going to blow out that candle. I don't want it to catch my garage on fire. So these right here are, come on, we're like trying to zoom in here. Come on, camera. Okay, it's not zooming, so I'll just have to live with that. But you can print this up. If you add a substance, the reaction shifts away from where you added, okay? So that was like over here. We add heat, equilibrium shifts away from it. Remove a substance. Okay, we've got our heat going. We take away heat. Now it's like we've got a hole in this reaction, okay? And things are gonna wanna flow this way to the right to fill it in. Okay, increase pressure, decrease pressure. I'm not gonna go into that. We just don't have time this year. Increase temperature, decrease temperature, we've used that as an analogy. Oh, adding a catalyst. If you add a catalyst, that just makes the reaction go quicker. And what it's going to do is it's going to favor, that direction just as quick as that one. So it'll make the whole thing go sooner. You'll get to equilibrium sooner. But it's just going to increase the speed that happens. So this is equilibrium, and I've got a little lab demo I'm going to show you now. I hope that wasn't too disjointed. Bye. Oh, yeah. Wait, York peppermint patty I just noticed was over here. Oh, I'm gonna make that disappear right now.